Okay, can we get started, please? Take a seat. All right. Well, thank you all for your patience and sticking around for the very last session. I know it's sometimes hard, but we keep the best for last. This is our IAB panel session. My name is Peter Christensen. I am a project manager and industry engagement advisor at PNNL. I help Wei and Amika with managing our industrial advisory board. And the purpose of the IAB is to provide strategic guidance and advice on prioritizing projects and just get their industry feedback to make sure that the AGI is as relevant as possible to industry. The AGI, or the IAB, meets 4 times a year, well, mostly virtually, and then 1 time a year we actually meet in person during AGI Day. So I really appreciate you all coming out, and very much appreciate your participation in the board. Is there anybody online? We were hoping to have a couple others online of the 8.
They talked us. They didn't show up.
Yeah. So we got. Okay. So again, the purpose of this session is not to have more slides. Promise, no more slides. But mostly make this an open discussion. So we're hoping to get a lot of interaction from the audience. So start thinking about your questions. This is an opportunity to get feedback from our industry advisory panel. But what I'd like to do first, though, is I'd like to give an opportunity for each of them. So I don't do the introductions because I'm lazy. I'm going to ask them to do their own introductions. Ask them each to give just a brief introduction of who they are, their role at their organization, and just maybe a couple minutes on what issue is that you think is probably one of the most important that faces either your organization or the industry as a whole that the AGI can or should be trying to address. So that's my first assignment. So we'll just go down the panel. So Mark, you want to start? No, we're going to start closest to me.
So why don't you pull up my first slide? Can you pull up my first slide, please? Anyway, I like to say thank God for the blackout of 1965. That's really been my career. Certainly, I remember the 1965 blackout. My grandmother lived in Brooklyn, New York, and my mother, we were living in Wisconsin at the time, and was quite stressed about what was going on there. Can you hear me now? Okay, start over then. I'll start all over. So I do remember the 1965 blackout. And I decided I was going to be an engineer mostly because of the NASA program, which IBM, which is where my dad worked, had some computers. And that'd be kind of cool because you're sending people to the moon and all over. So what didn't work out in my plans, obviously, because I was looking for work, and the only company that would actually pick me up was Northern States Power. So I joined the Mid-Continent Area Power Pool, which is MAP, which is now MRO, and that Resource Liability Organization, and MISO, that kind of split up and bifurcated. But it was a regional entity, and they needed a student engineer, and I did that for a summer and said, I guess I can do this for a living, and so I kind of majored in my senior year in power systems and joined MAP. I was a student in '79. Full-time in 1980. Joined EPRI in 1987 on power system planning and operations. I was doing some statistical analysis on transmission lines and ran some load flows and stuff like that. And then I was managing some great projects. I met some great people, learned a lot from them. And then did some international business development for a while, and then I joined NERC in 2007. And why I say that, thank God for the blackout, well, EPRI and NERC were formed in 1968. One, of course, one that organized it, Chauncey Starr, said, I want to be at Stanford, and the other guy said, well, I'll have mine at Princeton then. And that was kind of the starting point for NERC. We were actually on top of a dress barn when I joined them in 2007. There were only 30 employees, now we have 250, and of course, there's the regional entities across the North American continent, but mostly, of course, based in the United States. I would say if I were to look at what are some of the major challenges facing us, well, we covered a few of them today. Wildfires, I thought, well, but then we got this executive order from the President of the United States ordering the Federal, Energy Regulatory Commission and the DOE to study wildfire, minimizing wildfire ignition, developing mitigation without increasing costs to customers. And including, vegetation management, the removal of forests, hazardous fuels from transmission lines, improving engineering approaches, and safer operating practices. So I'll be looking forward to working with my colleagues here with wildfires, because that's going to come our way. Probably the Department of Energy is going to see some of that, so maybe we can kind of work together, because I'm sure you're Secretary of DOE and of course, Rosner and FERC are probably looking at as organizations. So clearly that's one. NERC has just recently issued its Reliability Issues Steering Committee report called RISK. And it identified a couple of areas that seem to be really important to consider. And obviously, cybersecurity continues to be an issue. How to design systems robust that can take on cyber events to a certain design basis, just like we do with land ground fault and stuck breakers and 1 in 10. What's the rules of thumb, how we design that system. I think the whole idea of the transformation of the grid, which will continue, may at a different pace. But, as we also have now a lot of large loads being built on the system. Clearly, large loads was another area that they were concerned about. Extreme weather, we are building a system that's much more sensitive to the weather, including gas. Gas doesn't always behave when you want it to. The gas system does not have to follow any reliability standards per se. So if they start freezing up their wellheads, well, tough, that's that day force majeure, or bonjour, not bonjour. But we're out. And so that's not a good day, obviously, for the electric system either, and of course, cybersecurity is what they're concerned about. So, so certainly weather is a major impact. We start talking about adding a lot of solar. And then now they'll put next to solar wildfires. What happens to wildfire? Smoke. What happens to smoke? It lays in the valley. And how much did you lose? About 80% of your solar can be reduced by the amount of smoke in the air. And so something we have to manage also as we start looking at future scenarios. So obviously the energy, making sure we have sufficient amount of energy. Where's it coming from? Where do you get your mutual assistance on energy? That is to say, when you have common mode type failures, common cause failures, where do you get your generation from when it's all going away? It's not like a tornado comes through and you call up to Joe next door and say, send me some equipment, send me some crews. You got to get transmission, right? So you got to have. So really, some of the rules of thumb that we've been working with over the years are really changing. It is changing quickly. What keeps me up at night, of course, is making sure that we balance all those balls in the air and still maintain a reliable system. So again, what I heard in the this last day here, a number of topics that I think will contribute to the reliable operation system. New technologies, be it for getting more out of the existing transmission system so we can build new ones. How do we get enough energy to load centers, data centers, without breaking the bank and being able to do it quick enough? How do we sell to the public the beauty of the power system and why it's so important to the nation and to their well-being, as opposed to stopping everything and anything that we build? I'm going to just quit now. Gene Rodriguez one time called me Dower.
Thank you, Mark. Excellent. All right, Eleanor from PSC.
All right. Well, first of all, I appreciate the opportunity to come and speak to everyone today. I'm Eleanor Uri, and I'm the manager of transmission strategy and planning at Puget Sound Energy. So I manage 3 engineering teams that are responsible for all manner of transmission planning for Puget. And anecdotally, I've been with PSC for 16 years now, and back as a brand new engineer in 2009, I started working on a project called Energize Eastside. Some of you may be familiar with it. And this was a rebuild of a 16-mile corridor within our service territory. And I was told at the time that that was going to be the biggest transmission project that I would probably work on in PSC. And 16 years later, we finally energized the last segment of it. It is energized and has been since early this year. But I will say now we're facing an entirely different challenge on our system, and that's the fact that we talked about the load increases this morning. We talked about the need for resources that are located remote from our service territory. So our last integrated resource plan identified the need for 14 gigawatts of resources that we need to bring into our system. And roughly half of that is located remote from the Puget Sound area. So now we're thinking about how do we develop transmission to get over the Cascade Mountains. And that's just the first step of what will be many steps to get to resources in Wyoming, in Montana. We're looking at North Dakota. How do we cross the boundaries between the eastern and western interconnections? And so thinking back to being a young engineer in 2009 and thinking that this 16-mile corridor was going to be a major project, and it was, but like, wow, has the industry changed just in the last several years. And the other thing that we're facing is just trying to get engineers in the door and trained up on transmission planning. It takes probably about 2 years to get somebody really proficient in running power flow simulations, in running transient stability, in understanding the unique needs of the system that we have in the Puget Sound area. And then you think about how can we make it better, more efficient, and I know AI has been just a hot topic today. And thinking about that human-AI interface and how it's going to affect the workforce that we need in the future. So we're not just looking for power system engineers anymore, we're looking for people that are educated in AI. And is that the same person? Do we have to train our power system engineers in AI, or do we need to partner somebody who's familiar with AI with a power system engineer so that we can make our processes more efficient? So definitely something that I've been thinking about just over the last few days. And then, of course, I want to touch on wildfire risk as well. I know that's been a big topic of conversation. From a little bit of a different perspective, we think about wildfire hardening for the resources, the facilities that we have in service today. We've been thinking about how do you plan your system in consideration of wildfire risk. If we have to grow the transmission capacity to get resources from where they're at to load, how do we know that the transmission system that we're planning is not adding increasing wildfire risk to our system? And thinking about some of the benefits that additional transmission can bring. Can we create fire breaks? Can we create staging areas for firefighting crews? Can we add additional resilience to the system by diversifying our transmission corridors? But then you're also adding risk where there was not electric infrastructure before. You're adding additional wildfire risk. So kind of changing the narrative around wildfire to how do we consider wildfire forward-looking as we're planning our transmission system. Yeah, those are a couple.
Excellent. Thank you, Eleanor. Very good. Mike, listen.
Hi everyone, honored to be here. Thank you for having me. So my name is Mike Diedish. I work at Avista Utilities in Spokane. I've been there for my entire career. Fun story, I'm a power engineer because of Anjan, but I'm sure most of you know Anjan. Yeah, we can blame him. I randomly decided I wanted to be an electrical engineer. Met Anjan while I was in high school at an event, and he said, "Oh, if you want to be an electrical engineer, you should do power." So here I am. So I think there's been such a great conversation throughout the day and many different technical topics and challenges. I think from my perspective, the number one challenge we're going to face, given all of these technical challenges, is affordability. And so when I'm listening to proposed solutions or challenges we're facing, I'm listening for what are those solutions that could improve affordability in the face of all of this change. So things that come to mind are how do we get how do we optimize our infrastructure investment in a way that we're utilizing it more? So basically improving load factor across the board would be one way to look at that. There's probably a lot of different ways to look at it, but getting the most out of the infrastructure that we have and then the investments that we need to make. Two, how do we become more efficient at building that infrastructure? We don't have enough people, time, or money to build everything we need to build to replace aging infrastructure, let alone take on all this new capacity. So how can we become more efficient as an organization? And how can we become better at change management? Because to learn how to use all of these new tools, technologies, new types of infrastructure even. We need people who can do that work. So I think, you know, change management, developing the workforce of the future is really important. I was talking to somebody the other day from our HR department who told me that 30% of our employees are new since COVID. So we think about like, oh, a lot of people are going to retire soon. They already did. Why am I here? They already retired. So I'll pick it up with you, Larry.
Thank you. Larry?
Thank you, and I appreciate that, Mike. Larry Beckett, Portland General Electric, Senior Vice President for Advanced Energy Delivery. As many of you know, was with Bonneville before Portland General, and then Clark Public Utilities District there in Vancouver prior to that, and Pacific Core for 17 years prior to that. So, been in the industry a long time, and but it's no more exciting than what it is today. And in fact, it was pretty boring for a period of time in there, and that's why I call it the missing generation. We are in a space here where, as you're saying, Mike, people retire, but okay, who's right behind them? And so we're missing some of that. But I think the challenges are in front of us, and what I would throw on the table first of all is to talk about the students. So any of you that are professors that are trying to bring students through, think about how AI should be working with them and how they can think through how to utilize it. So whether that be just in response, getting questions, how to ask the questions, that sort of thing, which some of us have trouble with. When you ask me. No, I'm hoping you'll teach me. But I think moreover is, okay, so how does machine learning really work? And how do I apply that with the technologies that I've got so that I can start to think, you know, from that view of how to use that technology and put it into play, whether you're in the operating room, you're out on the system, you're thinking about the equipment, the assets. You know, I think there's just a ton of space for us to try and take advantage of the technology that's there. So that's a challenge that all of us are going to have in the industry, is trying to learn as much from the millions of points that are out there and taking that information and optimizing the system. So that would be my challenge to all that are on the professor side of it, because we need that workforce. And they're hard to find. To Eleanor's point, let's take the transmission planners. Very few utilities, and we all steal from each other, and you know, people move around. But how do we take the tools that we have, whether it's Power World or Side, and feed it the data it needs faster? And instead of it taking us a month to do 160 feeders, we should be able to do that in 30 minutes. But it's got to feed real information into that front end of that system and start to help us with our planners to give them more time to think through, you know, what are these results really telling me, and do I believe them? It's not hallucinating, it's giving me the right stuff. So what we can do in that space, I think, is really important. The other one is protection and control. We're seeing, you know, the automation of protection and control. Doing the calculations on the live system, telling you, again, fault duties, everything else, and thinking about what should be the settings on each of those devices. And fortunate or unfortunate, it's working. And so we're going to see that coming, but how do we apply that to the workforce? How do we put that tool in people's hands that they then, again, can verify that the results are correct? And we're going to have to get comfortable with a world where it changes with the conditions of the system. So how do we put that into play? So the dynamic, not only ratings, but dynamic system adjustments. When does that happen? How does that happen? So it's really exciting, but it's scary too. And how are we all going to get comfortable with how those actions take place? Beyond that, I think all of us need to learn about data centers data center loads, what's inference, what's large load, or large learning models. How are those data centers different? How do they flex their load? They're doing it. They can do it. We as utilities are going to have to drive some of that, just like we put standards on other loads that have been in the past. We have to think about how do we drive the best benefit to create grid-friendly, if you will, loads that we can put on the system. Because we're not going to be able to build the transmission fast enough to meet all the loads. So we're going to have to think hard about how we get the most out of the system and at the same time meet the needs that they're looking for. But really do dig into what's inference-based, what's large learning models. You don't have generation that you can put alongside a large learning model, don't even bother. I mean, be thinking about the inference-based and how you can work with those customers. Large changes for us. It's an exciting time to be in business. Those are the things I would throw out there.
Thank you, Larry. Will?
Hi, I'm William Rambo, and I'm excited to be here as well, so I get to back clean up, so thanks for that. I am, I guess a little about me first. I am kind of culminating, or maybe I'm on a sabbatical right now. I'm ending a 35-year career and working with utilities. I never worked for a utility, but I got to work and provide services and technology to utilities for the last 25 years of my career. And it's been an amazing journey to be able to see what our industry is capable of. I agree, Larry, like you mentioned that there were some really boring times where there wasn't a lot of things going on. But like we have an amazing way right now that things are happening and transforming our industry. And we're going to have to rise to that challenge to be able to do this and meet these challenges. Today, one of the things I heard a lot of words like unprecedented. Somebody said it's a once-in-a-generational opportunity that we're experiencing right now. The level of investment that we're seeing in infrastructure in our industry is unprecedented. The load growth that we talked about today is insane. I mean, does anybody in the panel believe we're actually going to make that forecast in 10 years? I might bet Larry's retirement fund on it, but I'm not going to bet on it, all right? It's amazing to see where this is going to go. And there's only one way that this is going to happen. Well, I guess one other thing I wanted to say before I get to that is, Sam Altman just went before his investors, and he's, in the same breath, he's pitching that we want to invest hundreds of billions of dollars in AI, but he's also saying, well, we probably are going to see a bubble too. So that doesn't give confidence to be able to invest in infrastructure to be able to support these data centers. So that makes it even more interesting and more challenging to think about to do this. But I believe, like you alluded to, Larry, that AI is going to be a transformational force for our industry, and along with machine learning. And the only way we're going to solve these problems, one of the words somebody said today was, we have to think about this on a systems level. And these are complex challenges and complex problems. We're a very, very risk-averse industry. We're very, very slow to adopt technology. And in order to be able to solve these problems, we have to accelerate that change. Mike, you said change management. We have to do that. We're not going to make it through this unless we figure out a way to leverage organizations like the AGI, other organizations that we talked about today, to innovate our way out through these challenges and to solve these problems. So I think that's what I think today. We have to figure out a way to accelerate technology changes and kind of get out of our own way. One of the things, one example here, Larry talked about, we got to use AI and machine learning. There's incredible technology right now that we're not taking advantage of. So all three of the utilities here, they are not work. I just was a director of technology at Power Engineers. Power Engineers primarily does design engineering for utilities. So one of you guys would give me a contract for a substation design, and I thank you very much for a substation design contract. But what would we do? We would go to you'd send 5 engineers and techs out to that substation, right? I'd send 4 engineers out to the substation. We'd go out there because we don't believe what the GIS and the data is telling us, right? We've got bad data in our work we do. So we send 10 people out to the substation for a day. And what do? Everybody has a camera, or everybody has a notepad. We scribble notes, we do all this, we take it, we come back, and then we come back and we go, oh God, I forgot something. We go out there and get that again, right? So instead of that, what other industries are doing that we're starting to adopt, as an example of leveraging AI machine learning, I can take a LiDAR scanner out, and I can take oriented image of your substation, and I can send one person from my team and one person from your team, mostly just to let me in the yard, right? To make sure I'm safe in the yard. But now I can LiDAR scan that. As I'm going back and I'm uploading, I can take advantage of movie technology to upload terabytes of data to a cloud device. An AI and machine learning algorithm can actually start to build a model of that. What I would give you, what you want from me as a design engineer, I would give you a product. What am I going to give you? I'm going to give you a PDF, right? When did we invent PDFs? 1993, right? So now I can actually scan your substation. I can bring that in, I can create a reality model that I can have in a cloud. I can have a 3D ability to go look at it. Oh my gosh, I forgot that nameplate data. I just log in and I look at that, right? I've just saved 10 FTEs time for a day to be able to do that. Now, what can I do with that? So one of the things I think we need to innovate our way out of this is we've got to keep digitalizing our work. Somebody said this today, I think Crystal said, we've got to be able to go more digital. And going more digital enables us to be faster and better and break down all the silos we have to break down for our systems that we have to solve these problems for. So now, Eleanor's team needs data from this new substation design because it's a model, it's got a database attached to it. So she can grab the data she needs for her teams. Mike can grab data that he needs from there. It's not re-entering data from a PDF every time. So there's one example of a way I think we can leverage AI and machine learning and be able to be better, faster, and solve this problem.
Excellent, thank you so much.
I'm going to just point out,
Please.
I'm going to invite William over to the substation, just so he buys lunch.
Will does have his primary value is buying lunch.
Their credit card.
So, that brings a whole bunch of questions to my mind, and usually as a moderator, I take advantage of that, ask the first question, but this time I think I'll go to the audience. Is there anybody want to kick this off? Anybody have a question they want to bring to the panel? And we'll get that thing started right away, because I think that's going to be the most fun. Yeah, sorry. Over here.
I'm Scott from the city of Richland. Today we've heard a lot about data centers, AI being inevitable, that they're going to be on our grid. But if we look back in history here in central Washington, 40 years ago there was a big industry, the aluminum industry, that eventually took too much power. And basically, BPA, my understanding is, they said, sorry, we can't provide you power anymore. The industry went away. So I guess my question is it really inevitable? And are we setting ourselves up for a bunch of stranded assets if they just figure out how to make the computing take less power? Just want your thoughts.
Is that on? I turned it off. So, my recollection of history is a little bit different than yours. Of course, the steel industry built the airline and ships and planes that fought World War II. But the sense I got was we offshore. They got cheap someplace else, cheaper, and we allowed that to just leave. And in fact, the electric contracts that the steel mills had, they'd sell it because they get more money selling the electric, their contract they had than actually making steel. But that being said, that's an industry. My sense is just like anything else, to these industries and manufacturing, they come and I think, this is one of those that will grow, will change the way in which we live, will become almost critical to our life. Just like this doggone thing here. When you do a search, and now you do a AI enhanced search, and you're using energy. This should have demand response smart. So you reduce the power that you're using. But then think of the power that you have, the innovation capability. I remember when I started the industry, I had a Pride 400, holy smokes, a dumb terminal and a computer that batch ran. And now we can do all this stuff, and everybody can do this stuff. So I don't think it's going to go away. I think we're going to find new applications as it becomes more efficient. I remember in 1965, we got our first color TV set. We had one. With big sofas around, watching TV together. And we got 5. And everybody, oh yeah, that was my job. Turn the station. Don't do it fast, or you might break the channel. And now we got like 5, and everybody goes in their own room and watches their own TV show. And so I think this is a growth area, and I think it's going to continue. There is always concern about maybe there's like a bubble that we have with gas turbines, and there's stranded assets there. When we went to markets, there were concern about stranded assets for a while there too. There is uncertainty, to your point. That is, I think, that slows down investment. From the utility who's conservative because the regulators are breathing down their neck and they're not out there making the big play because it's so critical to society. But there is that uncertainty of where it's going to be, how much it's going to be. How much should I be building? And I think we need to get those folks to the table so they quit playing this cute game of shelling, going around and shopping around, and say, look, we need to make some decisions. It's in your benefit. They tell us, the large loads tell us, that we are depending on a reliable power system. We don't want to be ring fenced and do our own thing. They tell us they want that. They got to come to the table so we can eliminate some of this, hot air, right, in the business systems.
Anybody else? Yeah.
Can I really quick, Mark, if I go into the Northwest, so New Deal, 1930s, build the hydros, right? 40s, World War II, aluminum industry comes because of World War II. That's when all the transmission was built. That's when Bonneville came about. That's when we built here in the Northwest. And they helped to pay for that transmission. That took us to the 70s. And then slowly the aluminum industry left. You're right. Now think about the aluminum plant, 100 megawatts, 5 pot lines. You could turn down a pot line, 20 megawatts, 20 megawatts. Talking about flexibility, right? Exactly what the grid needed. Now unfortunately it was cheaper, or it was more lucrative for the aluminum plants also to turn it all the way down, and they'd make more money than they did on the aluminum. So to Mark's point, the ore and everything else was cheaper to manufacture somewhere else. They left. 90s. Chip manufacturers came in. We have now just filled everything back up. There is no stranded assets. So we have an opportunity right now to continue to build out the system of that future. And let's take advantage of that. Have those industries help us pay for those things. And we'll set ourselves up for the next round. But I can't think of the last time I've seen a stranded asset in our industry.
Great point. Anything else? Anybody, other questions?
We got stranded ties.
This is a comment on what Larry said about AI and how it's affecting education. It's very interesting you mentioned this, Larry. Just 2 weeks ago, we were in our faculty retreat, and this was a big topic, how AI is affecting education at the universities, because what we see, any problem that we give to students, they just have to make a PDF, feed it into ChatGPT, it solves the equations, circuit problems, power grid problems, and it gives you the answers. And so, we were discussing then now, how are we going to motivate them to learn these concepts? And again, how do we evaluate them in exams? And some faculty said it's very clear the students who are solving themselves or who are relying on other tools, because that shows up when they take the exam. But then we were asking the question, what is the best way that we train them for the future? Because it's a matter of fact, like you said, that these tools are available. So why not make that as a component of the curriculum, where we teach them how to ask these probing or prompts that would provide the right answer, and how do you judge if AI is not hallucinating, it's in fact giving you an answer that you can trust. So, this is something that we are still thinking about. So if anyone in the audience has ideas, how to,
Let me transfer that.
Yes.
Yeah, are your employees using AI to do everyday problem solving rather than hand doing it the way we do it?
I will let counterparts jump in too, but yes, we now have our own chat PGE that we created that internally we operate. But more than that, we have a design review tool. So, when those basic designs, these are not the substation level yet. But, line extensions to homes, et cetera, it gets reviewed and then gives comments, feedback right to the designer on the spot. So that helps them learn to think about, what was important, what did I miss, et cetera. And now we're doing the basic designs as well. So we're moving to that space. Forecast, flow gates, hydro facilities, you're seeing it in all kinds of spots. So absolutely, you're spot on. How do we charge up learning faster? Because, it used to be you made the assignment, they took it home, and then they'd bring it back the next day with the work, et cetera, right? Now it can be done quickly. So, okay, do I have to give them more? What is it that, I'm not sure what the right answer is there. I was challenging my better half, who's an English teacher, and saying that, okay, what do? Do you have them write more? Do you have them, I don't know what the right answer is, but there is something there that we've got to change how we think about in that education, using the tool.
When I was in college, I remember my sophomore year, I had a professor who thought calculators were just a passing fad, so he wouldn't let us use it. But Eleanor and Mike, just in TSE, what's your AI policy as far as engineering, just day-to-day engineering stuff, rather than the hard stuff?
So I think we're not as advanced as PGE, it sounds like you are, but we also have our own internal chat GPT, we call it Sparky. And so, we encourage use of it, but a really important component of that is that it is a version of chat GPT that has been taken offline, essentially downloaded, because data security is a really big issue. And so we don't want to be feeding an online version of chat GPT critical energy infrastructure information or telling it how to break our system. And so, it's kind of a fine line between how much do we allow the use of AI and how much do we kind of take that data security into account, and how do we protect ourselves as we're starting to implement tools like that. But I don't think we're quite to the point where we're using it for things like design, but we are kind of very cautiously exploring it at this point.
I was just going to say, we're obviously behind the other utilities in the room because we don't have a named internal AI system yet. But, I'm racking my brain. By the end of the presentation, I'll let you know. I think, Manny, getting back to your question about education, it's a really interesting topic to me. I think, you could go two ways. You could go, we're not going to let the students use this so that they have to do everything manually, or if it can solve the questions you give it, you need to give it harder questions. Because there's a lot of things that AI can't solve in the engineering world today, based on what I've seen. So I don't know what the right path is, but what I do know is that it's, from my experience, becoming an engineer, it wasn't learning how to solve this one problem that matters. It's understanding the principles behind how you solve that problem and applying that in unique ways. And that creative process is what the outcome is that we're going for here. And so finding a way to foster that ability in those students, whether it's through the use of the tools or through just keeping it old school.
Can I just suggest also about how can we use AI to train people? I've seen, some of these online iPad activity where they talk me iPad or they talk about using AI just to call it Uber driver, bring him in, and pretty soon they're building machines. and because the AI can train, rather than going through a tech school, how to run the equipment, how to be safe with the equipment. And so similarly, we can be using AI to teach students. So there are, when you think about all the other, think about how many errors and mistakes were made with Fortran code. How many innovative ideas died on the table because we couldn't figure out the bug. Now we have a tool that we can use that make engineers better, more effective, be able to learn quicker, to be able to tackle tougher problems than we had before. But it's a matter of how do we use those tools. Yeah, I mean, there's always we don't have, our policies don't use it. And though I know there's some people with their private phone will, give me great answers like this, so okay. But I think it makes you more effective so that you can really be thinking about the tough things. We've been working with Georgia system operator to look at how we write standards. And he recently put the Iberian Peninsula blackout in and said, NERC standards, do you cover all this? And it's created this huge dialogue within our organization. It's been just really healthy for the engineers kind of squishing their brains back and forth about voltage stability and transient stability. They love to talk about that stuff. And really, our standards really good enough to avoid something in the future. So, and I hope avoid some problems.
Well, you had some.
Yeah, just Manny, I think this is a collaborative area where industry and academia should be collaborating on, because we've been making tools. Larry talked about design smarter forever. This is just going to be another tool that we have to figure out how to use. And so working with how you train it and how you prompt engineering to do that and be able to add value for industry is, I mean, there's tremendous opportunity there.
You have to take up new technology very quick, new technology in the system.
That's a great question, Manny. Thank you. Next question. Yeah, you have.
Just commenting on what Professor Mani was asking from the audience. Within the last few months of my usage of this AI for queries and things like that, I think each one tool is behaving or specializing in some. I hope that it continues that way. We may take benefit of it. Individual tools, this tool is good for this tool is good for that. They announce that this is what we are. That would help a lot on using this. Otherwise, I've seen situations where it says, ask a probing question. Are you sure? He says, I'm sorry, I faked. So this is as if it is trying to emulate as a human. Humans' knowledge is limited to the extent of their own exposure. But here we have covered that single human, let's say, in this case computer or AI, to such an extent and trying to get answers. And some places he doesn't know, no expertise. So this is a real serious area that the regulation of thinking how to help these to the public in general. Otherwise, every single tool is trying to do everything, and that will get nowhere. This is one thing is a best practice. That's one. And on an academic level, I think I really subscribe to what he said, that a course should be introduced. Perfectly, though what should be the content of the course is a subject, but that is one thing, yes, definitely it comes to mind, even in each of these disciplines that we have. But finally, the uncertainty, we are in the age of uncertainty, what AI can do, I think we still have to evolve that. I don't think any, I can comment anything where we are going, honestly. Thank you.
The problem is it's changing every week.
Any other thought? Anybody want? Any other question want to raise? We can move on beyond AI. Yeah.
This is beyond AI.
I know we can talk about AI all day, but.
So Jeff Daigle, P&L. In fact, I was the inaugural co-director for AGI, and 18 months ago I took on a DOE headquarters assignment. So I want to let's thank Wei for taking over. They've done a wonderful job running AGI in my absence, and it's really great to see what's transpired. But my question for the panel, we talk about all these things we want to do to make the grid better, We talked about affordability, right? Where's all this money going to come from? Some prior National Academies reports I've been involved in talk about these engineering trade-offs, you know, between resilience, reliability, affordability, sustainability. These are all engineering trade-offs. You know, some things are not engineering trade-offs, like safety and security, things like that. We meet those standards. But all these other things are trade-offs. And the resilience report from 2017 talked about, you know, some of these things that we do for the grid are societal objectives, you know, like resilience. And so there's been historically a blend of ratepayer investment and taxpayer investment in these things. And the taxpayer investment's at different levels. Like after Superstorm Sandy, for example, New Jersey had a big grant, you know, $10 billion to reinforce that grid. We have the DOE Resilience Enhancement Grants and different things. And of course, PNNL is a federally funded research and development center, so we're very keen on federal investment in these types of things. Where do you see the future of that? You know, do we have the right messaging? Do we have the right stakeholders lined up? Are we headed in the right direction? Or are there big concerns that you might have in terms of where we'll be 5-10 years from now, based on, you know, who's investing in this stuff? And are we going to end up in the right place?
Just some initial thoughts. Just some initial thoughts. Yeah, we didn't touch it. I think, you know, and of course, I think it's IEA that has this measure of the trilemma, right? The sustainability, the affordability, and the reliability / resilience. And some countries do very well. I mean, they're 100% hydro. Sweden looks, hey, look at that, looks great. We are not blessed that way, but though we do pretty well in North America. I think that we've seen, a little bit of push toward the sustainability leg here over the last couple of years. And we've seen the result in two areas. One is the prices, in some cases going up quite high, and also in reliability. We talk about energy and Dunkelflauten, where the wind ain't blowing for 60,000 megawatts and generating 200 megawatts. That could be a bad day. Smoke-filled valleys where you have all your solar panels because of the fires. We have this climate change we're dealing with. It's going to continue because being dour here, other countries will continue to burn fossil fuels like crazy because it's a better life than what they have now, which is without those fossil fuels. They don't have a lot of alternatives yet. They have targets of 2070 and 2080. I'll believe it when I see it. I mean, I talked to Edison the other day, and you know, so I think you know that continues to be a balance, and I think you make a very important point here: is how do we get that balance tuned well, and how do we get society, you know, the public, to understand what that balance is all about. And some folks are blessed with more renewable energy in some parts of the country than in other parts. How do we share that transmission? How do we do a better job of you know, taking advantage of the resources we have? And you know, for example, I always talk about the line that goes through Indiana, like a truck going through Indiana. Doesn't stop, doesn't get gas, just keeps riding, uses the turnpike, doesn't take toll. Brings some back roads, gets to Chicago, unloads, and brings all those goods to Indiana. Did Indiana benefit from the truck coming through? Yes. They would benefit from the line coming through? Yes, absolutely. When we have data centers, they're in Florida and they're using their phone, they're using a data center in Virginia. Are they benefiting from the data center? Yes. So there's some society benefits there we got to figure out. I think we've done a good job of that.
That's a great point. I also want to just hear from others about that same question, but I think a really key point of what you talk about, Jeff, is communication. And I don't think utilities, the industry, well, not just utilities, the industry as a whole has never done a good job of explaining the value of electricity. I tell a story all the time about you turn a light switch on, people don't even know what goes on behind that. And so how can we, when you talk about that balance, you know, those areas, how can we as an industry do a better job of communicating that and asking for feedback? You know, where do we want to make that balance? What are your thoughts about how we can do a better job as an industry in doing it? That was a tough
You
one.
said a community event last night, right? That's pretty cool.
We were there. Back out again. Do we have the right mix? You know, there was some public funding for some projects, et cetera, seemed to be, you know, helpful. It's hard to measure with, you know, again, customers and affordability. You know, what we've heard from a lot of communities is that, okay, if the price is going up a little bit each year, we're okay with that. Big jumps, we don't like. And we got caught with that. We didn't raise any sort of pricing through COVID, et cetera. And then all of a sudden, boom, a big increase, and it didn't go well. So, so yes, people understand the incremental, but they also, to your education point, when the energy wallet is changing, now all of a sudden I have an electric car, I'm not paying for gas. But I'm not thinking about that because I'm just thinking about the utility bill that I get, and my utility bill went up. So, again, the concepts, you know, and how do we evolve in how we talk about it, and the values that we give. One of the great examples I heard recently, you know, we talk about demand response, and you know, again, how do you pay customers for participating, being in those programs? And you know, it was brought up earlier, you know, we want to get more people involved. In Europe, England in particular, they have a program now that when you participate and the utility then, you know, has benefits from it, et cetera, they give free hours maybe the next week. And so, or maybe you have happy hour for the small businesses, et cetera. But that, you know, translates, customers understand that easier than, oh, you gave me, you know, $5 last month. You know, what did I get that for? How did that work? So making the connections between, and I think electric vehicles made the connection much better. And again, we got back into understanding that, oh, I got to charge this thing. When do I charge this thing? How much does it cost? Is it convenient? You know, you had to live it a little bit. And now you pay attention to those things. But we have to do that in general to say, what's the balance here? How much on wildfire? How much on transmission bill? How much on, you know, and what are you doing in the community? And as you mentioned last night, community that has 80 megawatts, kind of in general, we're building it out, so we add another 40 megawatts for this community, but it's grown 3 times, you know, what it was. Again, just trying to paint the picture to say, you're growing, it's a good thing, but at the same time, there's a cost associated with all of that, and how do you bring that message across? But we actually, as your point, engineering has to come through to say, these are the best first steps, these are the most cost effective, and you want to see where it does multiple things. So it doesn't just solve the wildfire, it also solves other issues that you might have on the system as well. So look for the stacked benefits.
Any other thoughts from Mike?
Yeah, I love your question. I have a lot of different thoughts, but I don't know how to articulate them very well. So I'll just kind of pinpoint a couple challenges. So one of the challenges is not having funding within our utility for, you know, research and development. So the things we do are not research oriented. They need to be putting the plant in the ground. And to some extent, it's hard to innovate in that environment. And so what we've done in the past is go after grants, right? So within the Innovation Lab, most of our projects have been grant funded. We learn a lot through those projects, but they're not scaled infrastructure projects. They're more on the demonstration scale. So trying to get that knowledge into the utility, but it's small, right? So we would benefit, I think, from being able to innovate within the utility, train our people via some funding mechanism. Is there a way that we can partner as organizations with each other in a more programmatic way versus a project-by-project way? I think that would be one possible avenue for, you know, solving that particular problem. The other one is a lot of times when you look at the funding sources, you mentioned an example back east, but the funding from the grant perspective that utilities have or had available to them are often around like a specific topic or idea, and not around, hey, just build some lines where you need them or collaborate regionally to expand transmission. It's more like it has to have some unique flavor to it and some other requirements. And so that's another challenge that holds us back from that affordability perspective and advancing our system quicker. So, yeah, I'm willing to listen if anyone has ideas.
Your thoughts? But let me take again, my opportunity as a moderator to jump in and ask my own question. So I'm going to completely shift gears here. I heard a lot today. We heard a lot talk about transmission. We heard a lot about distribution. But they're always traditionally in a context of those are two separate things. And I think we all agree that the boundary between transmission and distribution is getting fuzzier and fuzzier, almost to the point where you always have to kind of, how is your organizations dealing with that boundary between transmission and distribution? I imagine in my utility days, those were two separate groups that didn't even talk to each other. I don't think that's the case anymore, but I'd like to hear your organizations, how they're dealing with that transmission-distribution boundary.
Peter, you shouldn't give Mark an opportunity to answer this question.
Eleanor stole the microphone
And
from Mark.
it's because of the regulations that may fall out.
All hours, it's all hours.
Yeah, and I would just say the short answer is we're not dealing with that very well. And one of our challenges is we have our transmission system models. We have a very robust process with WEC to maintain our transmission system models. We use Powerworld software to run our simulations. On the distribution side, we're using Synergy, and it's a completely different database internally for where they get their information and where we get our information. And so, the coordination that we're doing right now is really just in the transmission planning, talking to distribution planning about where are you seeing load growth, how can we incorporate that into both of our models.
I'm also thinking too of DERs. I mean, just the fact that there's so much generation now on distribution, that's something that's now transmission group has to start thinking about. Yeah, absolutely.
Yeah, and I would say we're in maybe a little bit of a unique situation in the Puget Sound area where a lot of our distributed energy resources, like the rooftop solar, typically isn't impactful to our system peak, which is how we plan our transmission system. So there's maybe less correlation there for us, but it is still something that we're cognizant of. There's distributed energy resources on our system. Do we have the right visibility of those? Do we really fully understand how those are impacting our peak load hours, which is what we're planning the transmission system for? And so I'd say there's a lot of opportunity in that space right now to help coordinate, streamline, align our models and our data. But yeah, definitely an opportunity.
Yeah, thank you. Well, how about you? You've dealt with a lot of different utilities. What's your experience in some of the big IOUs that you've dealt with? How are they doing?
I mean, I feel like the Northwest still, with our power prices being low, and we don't have the DER penetration that the Southwest has right now. So we haven't been on the sharp tip of the spear there. Utilities have not here that we work with, and so there's still not the urgency there. We're seeing, you're seeing your budgets increase on the distribution side, and it's starting to do that. But we certainly see, the Southwest and areas like Hawaii have been that way for a while, right? They've struggled with this problem. It seems like until we start getting, P&L has to get a better battery so we can put more batteries behind the meter, and that's really what could drive, I think, the Northwest to get that way. But until we start having storage, a lot more penetration of that, and creating more assets that could be shared behind there, I think we're a ways away from really having a huge problem right now in the Northwest. The penetration just isn't there. So from a planning standpoint, I agree. We just haven't seen it. So.
Certainly some utilities have, and that's why I asked the question.
Yeah, well, and you have new players, Caterpillar. They have all those engines out there. run really reliably, and they're actually looking at getting in the business of aggregation. You know, I just bought a demand response company, and of course they have it all in the cloud, which scares the living daylights out of them. But they want to start playing, right? They want to get into the markets. And
Biggest move in Distributech, right?
Right,
There you
exactly.
go. Yeah.
And they're not alone. There are the other machines out there too. So there's some new players in this market that could change. But you know, I always say that as soon as I become dependent on that generation to support the reliable operation of a power system, then I'm interested in what it's doing. What are the contributions to reliability? Is it just going to say goodbye when there's a line of groundfall? We've all been down through that. So, and we learned something what happened at Iberdrola when they started to try to restore their system when they couldn't manage voltage and trying to back their way back out of it and having to try to manage all this stuff on the distribution system keeps coming back on again. So this is two-way switch, right? And how did they restart that system when a lot of the inverters they had were not grid following, so they looked at the frequency and all that. So there's something to be learned there because they have such a large amount of penetration. So we're at least ready for it.
Okay, yeah, Manny?
Yeah, I am reacting to the comment from Mike. You know, we are going through this really unusual times that the federal government is cutting down on research and development investment. The power industry historically, like Mike observed, has been one of the least invested in this area in investing towards research and development. But now that, like everyone says, we are in these unprecedented times where we need to be thinking about novel solutions, innovations for solving the challenges. And as the funding from the federal is at least being reduced, will the industry step up in maybe increasing the funding towards research and development and becoming more proactive in developing these technologies?
Thank you for asking this question.
A couple quick thoughts on that. One is, of course, this is an industry that needs investment, and it does need investment. R&D as well as support its long-term health. There's no doubt about that in my mind. I think one of the challenges we have with hard technologies versus software has really been a problem for our industry, including even the acceptance of power electronics, which, you know, in many cases could revolutionize our industry. We'd be building a giant computer. We got chips already with solar panels and inverters. So, you know, we're taking the steam out of it, we're taking the rotation out of it. It's more of an information system, right, in the long term. The giant machine is becoming a giant computer. The question is, can we get also investors like, you know, venture capitalists more involved as well? They always look for that short-term hit, right? How do we make sure that those funds are used for a longer-term hit? Whereas in the utility industry, working with venture capitalists, perhaps a little bit more, so we get beyond that death by piloting. So I think that there's also been this kind of difficulty of getting from the shop, at the R&D shop, into the industry, and an industry that's kind of resists change. And unfortunately, this is an industry that's going to have to start accepting change, be part of change, so that we can get to that system that really the public wants.
Yeah.
But that doesn't get you a dollar bill in your pocket.
Man, it's really, I think, from an IOU perspective today, you know, where we've had access to capital and bringing that investment in and applying it. Wildfire has hit us all really hard. So you see stock prices that are down 20%, and that hurts. And on top of that, now you're certainly hearing from public in general about rates and are hitting us and making it difficult. So Mike says he wants to get R&D dollars to go and try advance his system. He's not going to get the R&D dollars. I mean, that's the hardship that we're faced with right now. So these partnerships really do matter, and it'll be interesting as budgets continue here after Labor Day. We'll see how our DOE comes forward with funding, et cetera. You get signals that this industry, advancement of data centers, advancement of the transmission, the generation, you see the signals that these are all really important things for this administration. I guess we'll see. But it's not simple. And the last thing that any of us want is a reliability issue to take place. And then we'll have all the policymakers wanting to fix it for us. So, it'll be back to 1965.
I'm sorry, I thought you guys.
No, you're good. I can go. No, I think the good news, Manny, is that there is, because of the level of investment that has been, the increase in investment in the industry, it's attracting venture capital, it's attracting private equity now. So we have private equity buying big consulting firms right now. So we're seeing investment in the space that I was in that's never happened before. We're having a lot of startup investment now because there is the level of investment that the utilities are making in infrastructure. There's a lot more startup dollars and venture capital on AI startups and other automation startups for the industry. So I think we have that talent pool that hasn't, during my career, it's never been there. So I think we need to figure out how to take advantage of those investments as well to solve these problems more.
Yeah, so I was talking with Brett. Hi, Brett. It's about data centers and the investment. So if we think the utility industry is investing a lot in infrastructure, the scale is totally different when it comes to what these hyperscalers are doing financially to build out these data centers. And I think to some extent, in terms of stepping up to help out with that, it's those very, customers providing the need that might have to help step up and provide some of these solutions so that our other customers aren't impacted. So we can serve what I would call like normal utility needs fairly well, right? I think we know how to do that, but to serve to double our system in 5 years, it's going to be a huge burden on our customers. And so I think those companies who are benefiting the most from the technology are the ones that can provide some capital for infrastructure.
If you would mind, man, I'd like to just put my 2 cents in on your question, just because I've come a lot of experience trying to get tech transfer, doing tech transfer from laboratory projects into the industry. And I think when research dollars are minimized, I think we got to be very efficient with what dollars we do have. And I think we do that. The best way to do that is to work with industry from the very beginning of those projects to make sure that they're very directional and that there's a path towards deploying those technologies, not just academic exercises. I mean, it's great to write a paper in a journal. But if we really want to get the most out of those dollars, the few dollars we do, I think we need to work with industry from the very beginning to make sure that it's going to go toward really solving a problem. That's my fluffy buddy 2 cents. Any other questions?
I have a question. So I live and work in Centralia, Washington. And we're talking about the future a lot today. What's going to happen in 10 years, 20 years. What's going to happen in 2026? TransAlta is closing at the end of this year. We're losing a power generation. Do we have enough generation in what's moving now? Any extra to cover that loss? First time I came to AGI was in 2021, and Larry said we can handle the closure of one power plant, but we can't handle the closure of more. We weren't even talking about data centers back in 2021. So what does 2026 look like for us on the other side of the Cascades?
Fusion.
It's not going to be here 2026.
So I get to pass on this one because I'm from the actual east side.
Oh, boy. Well, two comments, I guess. One, Centralia, where it's located, is a really important spot for both the north and the south on the I-5 corridor. And so it is a worry. I think the other, we have seen an awful lot of south to north flows. And it's our friends to the north and to the north of the north who have been sucking a lot of, again, solar from the desert southwest through our system on up the I-5. And you're seeing pooling in Canada during what would be the normal season we'd be using their reservoirs, et cetera, and their pooling water. That tells you something. They're using a lot of energy that's coming from the south. So our flows are different. When you take that element out, I worry that when it comes fall and spring, and that's when we start to see, again, and we can use that northerly generation to push against and move energy from north to south instead of south to north. So I worry about that could be an issue. But maybe you could start the rumor that Whoops is going to reopen.
Another kind of hearing out there is the recent executive order that DOE responded to. They worked a little bit with us on basically reliability. Where are the tight spots in the country, and where are we seeing an acceleration in retirements? And they issued their report, and we had some comments on it, but overall, basically identified some of the same areas. There is a section in that executive order that they have not finished yet, and that is which units are coming off that should be coming off, that are needed, and how they're going to keep them on. Now, some of these plants are going to go with clunkers, really shouldn't be on. I don't know what criteria they're going to use, but I know that there is that federal action. Think of Brandon Shores, and there was a 202, DOE 202. Yeah. Thank you. So there's some of this stuff out there that's hanging. I don't know if we're going to continue at the same pace in the country as we had over the last 6 to 8 months into 2026. But my sense is, based on what we've seen from the government so far, the federal government so far, is data centers, yes, AI, yes, keep the generation you got, keep it running until you can back it up with something else. So that's what I'm hearing. I don't know if that's what's going to happen, but crystal ball is not here.
We're almost out of time yet. One more quick question.
All right, I read last week that California deployed their VPP. There's about a 500 megawatt demand shift from BESS deploying. They have over roughly 2 gigawatts of BESS deployed. So we didn't call on all of it. There was more capacity there. Also read that if we said thank you every time we queried ChatGPT, that would equate to about 10 gigawatts of demand for electricity annually. Been looking at PSC's IRP or ISP and RPAG, saying 38% of substations need to be upgraded in the next decade to reach demand. So my question is this: would you rather hire a power? This is a heretical question in this room. Would you rather hire a power engineer or a software engineer, and why?
I would hire a power engineer who can code.
That's great. That was a good answer. A great question. I know we're out of time. We do have a reception coming up, but I'll let you talk about it, and I assume at least some of you will be there, so this discussion can continue during the reception. Again, it's a great discussion. I don't mean to cut it off, but I do want to keep us on schedule. So, thank you. Let's give a hand to
So before we start our closeout session, so there will be a surprise to you, Peter. So some of you may not know that this AGI Day will be Peter's last AGI Day because he will retire soon later this month. So first, congratulations. And also we'd like to thank you for your contribution to AGI, especially your contribution to our industry advisory board. We cannot be so successful with your help. So from all of us, we'd like to wish you a happy, healthy, and fulfilling retirement. Congratulations.